welcome to a totally educational video about
magnetism.
Shut up! Magnets have two sides, both attracted towards different ends of the Earth, called North and South Poles. You might have heard of them somewhere before. Anyways, you might think that one side is stronger than the other because of the color or distance, but no. They both have the same power and are both equal. Magnets are generally made out of nickel, cobalt, or iron. No, not that iron. Some exceptions are a few rare earth metals and minerals.
what were magnets made from in the past. A long time ago, magnets were found in the form of natural magnets known as the lodestone or magnetite. But these were all just rocks. Magnets were discovered by a Greek person named Magnes. One day, Magnes was sitting on a magnetic rock with a stick that had an iron tip. Then, something magical happened. His stick had stuck onto the rock. He decided,
The discovery of the century, I must quickly name it before anyone else does. I shall call it a lodestone. If that is the rock of the people, I shall call it a magnetite.
Sometime later, in 1603, an Englishman by the name of William Gilbert discovered that the Earth was behaving like a giant magnet, and then the Chinese invented the compass. No.
as you can see, we can make a magnet with electricity. The artificial magnet is called an electromagnet. How do we create the electromagnet? First, you'll need one nail, preferably a big one, 1 meter of copper coil, a lot of paper clips, bench power unit, and 2 crocodile wires that will be used to conduct electricity.
First, you need to scratch the copper coil with sandpaper for the sides, like this side and the other sides too. Then run up the copper coil around the nail. Remember, you need to leave some copper coil on the sides. After doing that, connect the crocodile wires from the bench power unit machine to the copper wires that are left inside. So here, I'm gonna connect it with it, and then yeah. Yes. So then you put it to the hyperglass.
You all need to know the safety of the bench power unit machine. In the bench power unit machine, there's a DC code, AC code, power switch, reset button, and dial of volt. Before you do anything else, you always need to make sure that the bench power unit is turned off when you're trying to connect the wire to the coil. Second, you cannot match the dial to 5. You can only match 1, 2, 3, and 4 for making an electromagnet, not like 5, 6, 7, and so on. The last thing you must know is to connect the crocodile wire in the DC code, not the AC code.
I did a mistake. So connect the wire to the copper coil before you turn on the switch. Finally, the copper coil gets warm and the paper clips stick to edge of the nail.
Okay, so hi everybody. So I'm gonna be naming some of the uses of magnets. One of the most obvious and interesting uses is the compass. And as we can see here, this is a compass. It shows us the north and south, west and east. It shows us where to go. It's very useful for sailors because they need to know where to go to trade. Isn't that right?
Alright, that's great and all, but do you know how they work?
No.
Too late, I'm answering it for you. The needles inside all compasses are magnets, so they're attracted towards the two poles on opposite ends of the Earth. The end that is either longer or is a different color will always be pointing to the north, while the shorter end will always be pointing to the south. All magnets have something called a magnetic force. It pushes or pulls objects. For example, like when things are different poles, it pulls them together. However, when things are opposite poles, it pushes them away. So, what is a magnetic field? A magnetic field is the region surrounding a magnet in which the force of the magnet can be experienced. There is a picture up there showing how the magnetic field works. Lines that are surrounded by the magnet are called magnetic lines. Magnetic lines always start at the north and end at the south. Inside the magnet, these lines are directed from north to south. Therefore, the field lines form closed loops. How about the strength of the magnetic field? We can see the closeness of the magnetic field lines tells us about the strength of the magnetic field area. The more closely packed the lines, the stronger the magnetic field area. The Earth also has a magnetic field. The Earth's magnetic field is known as the geomagnetic field. It is the magnetic field that extends from the Earth's interior to where it meets the solar winds, a stream of charged particles sending out from the sun. There is evidence to prove that the Earth has a magnetic field. When you see the compass, the north is pointing to the North Pole and the south is pointing to the South Pole. Do you know why? Because there is strong south energy in the North Pole and strong north energy in the South Pole.
Still not a follower of magnetism. The other evidence is the northern and southern lights. Do you know how these lights are made? These lights are caused by the Earth's magnetic fields. Like sometimes the sun throws out a burst of energy. These bursts get caught around the Earth and they give a beautiful light of the northern and southern lights. Follow magnetism. The